Gradeup National Scholarship Test for ESE and GATE stand a chance to win for a scholarship pool of 50 lakhs. Register for free today.
Good evening, everyone. Welcome to India's largest e-learning platform, Gradeup. And welcome to the session 25 most important topics for GATE CS 2021. Join the session quickly. I am waiting for you all. Salo Kumar, good evening. Join the session quickly and mark your presence, everybody. Today, we are going to discuss the most important topic from computer organization and architecture, that is instruction pipelining. In the last class, we have discussed about cache mapping techniques, which is another most important topic in computer organization and architecture. Today, we will discuss instruction pipelining. Before I start, let me introduce myself. I am Satya Kaitepalli. With all these credentials, I teach computer organization and architecture, computer networks, operating systems, data structures, and algorithms. A gentle reminder for everyone that Gradeup is conducting a Gradeup National Scholarship Test tomorrow, that is 19th December. Please do register and get a chance to win scholarship up to 50 lakh rupees. Try to circulate this as much as possible, guys, and do participate in GNST. And here are the details about this GNST. This exam happened in two stages, stage 1 and stage 2. Stage 1 is tomorrow in 3 slots at 12 o'clock, at 4 o'clock and 8:30. There is a buffer time of 30 minutes for stage 1 and the test duration is 60 minutes. You can attend this session from your mobile app or mobile desktop. Result will be displayed day after tomorrow, that is on 20th. And this is the syllabus, guys. For stage 1, engineering mathematics, that is linear algebra and calculus and general aptitude. You will be having 20 questions from engineering mathematics, 10 questions from general aptitude, all will be of MCQ type. And for stage 2, for computer science students, data structures and graph theory, that's it. That is the syllabus. It would be of 90-minute exam with 35 questions and there will be 20 MCQ, 10 NEAT and 5 MSQ type of questions. Okay? Do attend this GNST, guys. In the last class, I have discussed about this cache mapping techniques. As we discussed, there are 3 types of mapping techniques: direct, associative, set associative. In the direct mapping, the CPU address is interpreted as tag, block and word offset. If it is associative mapped cache, it interprets this as tag and word offset. If it is set associative, this will interpret the CPU generated main memory address as tag, set offset and word offset. With direct mapping, hit latency is less, but conflict misses are high. With associative mapping, hit latency is high, but conflict misses are 0. With set associative mapping, both hit latency and conflict misses are less. So this is the quick consolidation of last class. No, I am not from Tamil, but I am a South Indian. Salokumar, Chandana, Abhishek, welcome to my session. So today's topic is instruction pipelining. Guys, we know for completing any instruction, multiple stages are required. So those multiple stages are involved. They are generally, what are the stages involved in completing any instruction? Instruction fetch. What is instruction fetch? Loading the instruction to be executed from memory to CPU. This is called instruction fetch. Once the instruction is fetched, that instruction should be decoded. What is the meaning of decoding? Preparing the sequence of execution or sequence of operations to be performed. Which will do decoding? Control unit will do decoding. Once decoding is done, then it may be required to fetch operands, or you may find this as register read. So to perform the operation, whatever the input operands or source operands that are required, accumulation of those source inputs, that is what we call as operand fetch or register read. And then execution. Once instruction is there, we know how to do, and inputs are ready, then doing the operation, performing the operation is called execution. This is done by ALU solely. And then you can say memory phase or write back phase. This is once operation is done, store the result back. Generally, these are the phases involved in completing any instruction. In these, instruction fetch, instruction decode, execution are mandatory phases. For any instruction, these three phases will be compulsory. The other two phases are optional. Some instructions may have 4 stages, some may have 5 stages, some may have 7 stages with the different terminology. So 3 stages will be there compulsorily for any instruction. They are instruction fetch, instruction decode, execution. Once for one instruction these are done, then for the next instruction again instruction fetch, decode, etc. So this is a cycle. This is a cycle, right? Now, as for every instruction, the number of stages are not fixed. Let us generalize now. Let's say there are 4 instructions each instruction executes in 3 stages, and each stage time is, let's say, 2 seconds. Let us suppose there are 4 instructions to execute. Every instruction to execute, there are 3 stages. Every stage takes 2 seconds of time. Now, to execute these 4 instructions, what are different modes, forms? So, what are different modes of instruction execution? In what different ways these 4 instructions can be executed? There are 3 different ways. 1. Serial processing. What is serial processing? One after another. First, instruction 1, stage 1, stage 2, stage 3 are done. Then, second instruction, stage 1, stage 2, stage 3 are done. Then, third instruction, stage 1, stage 2, stage 3 are done. So, one after another in the serial manner if we do, this is serial processing. What is the total time needed to execute? For one stage 2 seconds. So it is 2 plus 2 plus 2 plus so on. So total 18 seconds of time is required. 18 only? No. Okay, 4 instructions are there. Not 18. How many? 24 seconds of time is needed. Right. But is this the only way to execute? No. There is another way. We can say parallel processing. What is parallel processing? All instructions first stage happens at a time. All instructions second stage happens at a time. All instructions third stage happens at a time. In this way also instructions may be executed. So what is the total time? Here one stage takes 2 seconds. Total 6 seconds of time is needed. But is it possible to execute multiple instructions in parallel? Can all S1, all S2, all S3 happen at a time? In practical, it may not be possible. Due to limited resources, parallel processing may not be possible, is not feasible to implement. Though it is a good idea, but we may not implement that idea in practical. Then, is there any better way? Yes, that is what pipelined execution. So, what is pipelined processing? We are unable to perform all S1, all S2, all S3 at a time. That means similar stages we are unable to perform at a time. So just make that as a good idea for pipelined processing. Make sure no two similar stages overlap. That becomes pipelined. So if I have first instruction I1, it execute its 3 stages without any overlap. Second instruction also should execute its 3 stages without any overlap. Third instruction, fourth instruction. So if you see this, at any given time, no two similar stages are overlapping. No two S1, no two S2 and so on. This mode of execution is called pipelined processing. And what this is, this representation is what we call as space time chart. Instruction space on one axis while time in another axis, like this. So what is the total time required here? For one stage, 2 seconds of time. Here we are doing this in the form of 6 stages. So total time is 12 seconds of time. Right? Now let us generalize this. There are 4 instructions we have take, 3 stages per instruction, and each stage is taking 2 seconds of time. Now if we generalize this to there are n instructions, every instruction is requiring k stages, each stage time is small t. Then what is the total time in serial processing? This is n into k into t. Number of instructions 4 into, number of stages 3 into, stage time 2, that is 24 seconds. Similarly here, what is the stage time? K into t. Then what is the total time in pipeline processing? N minus 1 plus k whole into t. Except first instruction, all the other instructions are dependent or having this constraint for every stage. What? Overlapping constraint. Now, which is best in these 3? Parallel processing is best, no doubt. No doubt parallel processing is best. But that best case is unable to implement in real. That's why pipelined processing is the better case. Okay. So now if pipelined processing is also not possible due to some reason, then what is the option left? Serial processing. Hence, serial processing from now onwards we will refer as non-pipelined processing. Non-pipelined processing. Okay? Fine. We have serial processing, pipelined processing now. Forget about parallel processing because it is not possible. Before we go further, let me introduce quickly our innovative, useful courses at Gradeup. They are Gear Up, Rank Up, and Vision 2022. Gear Up is to become your concept stronger. Rank Up is for improving your score with more and more practice. Vision is a long-term course which is ideal for 2022 aspirants. So these are the highlights of all these courses. Not only these courses, any other course that happens for GATE, ISRO, BARC, NEELIT, DRDO and any PSU exam, how you can attend them? Just with one subscription, that is Gradeup Super. Take one subscription and you can enjoy all these live classes. Who will teach all these? Currently we are the faculty pool at Gradeup in CS category, Mr. Murali Krishna sir with 20 plus years of teaching experience. It's me with 13 plus years of teaching experience. Mr. Ankit Doila with 8 plus years of teaching experience. Mr. Navneet with 7 plus years of teaching experience. Definitely we can train you well, guys. Now, so forget about parallel processing. We have non-pipelined and pipelined. So on a computer which is doing serial processing, if you apply pipelined method, definitely speed increases, performance increases. Yes or no? Definitely yes. So what is that speed increase or speed up or performance gain? We can say that as non-pipelined time divided by pipelined time. So what is that? Speed up is equal to non-pipelined time is n into k into t. Pipelined time is n plus k minus 1 whole into t. So what it results in? Speed up is equal to n into k divided by n plus k minus 1. But when this is the case, whenever stage time is uniform, when the stage time is uniform, means every stage of every instruction is taking same time, this is the case, right? What if stage time is non-uniform? We will see that. Before that, efficiency of pipeline. What is efficiency, guys? To understand efficiency, we know that speed up is equal to nk by n plus k minus 1. Now, when n is much greater than k, n plus k minus 1 results to n. Like example, let's say n is 10,000, k is 2. Then n plus k minus 1 will be 10,001. That is almost equal to n. So, when a processor is executing many instructions, what you get? You will be getting the maximum speed up or ideal speed up. So, what is that? N into k by n plus k minus 1 is going to n. So, what is the maximum speed up that you can get? K. Now, efficiency when you wanted to calculate. What is your efficiency in the exam? How do you calculate? Obtained marks divided by total marks. In the same way, what is efficiency of the pipeline? Achieved speed up over maximum speed up. Like S divided by S max. So efficiency is, what is the speed up? N into k by n plus k minus 1. What is S max? K. So what is efficiency? N divided by n plus k minus 1. Now, what is throughput? Number of instructions executed per, or you can say number of instructions executed in the given time, in the total time. That gives you throughput. So what is the throughput? How many instructions you execute in the execute n, and what is the total time? pipeline time, n plus k minus 1 into small t. Let me call this as equation 1, this as equation 2. From equations 1 and 2, we can derive the relation between efficiency and throughput. How? Efficiency divided by small t gives you throughput, or throughput into small t is equal to efficiency, right? Now, what if there are non-uniform stage delays? Then how do you calculate pipeline time, speed up? Example, let's say there are 4 instructions, I1, I2, I3, I4, with the stages S1, S2, S3, with the delays 3, 2, 3, 2 units, and 3, 1, 1 unit, 1, 1, 2 units of time, 1, 1, 1 unit of time. Like every instruction, every stage is taking different time intervals. Now, what is the total time in non-pipeline? Means serial, nothing but sigma, summation. 2 plus 3 plus 2, that is 7 units of time. 3 plus 2, 5 units of time. 2 plus 2, 4 units of time for I3. 3 units of time for I4. So what is the total? So total non-pipeline time is 19 time units. But if we want pipelined time, then what you have to go for? You cannot apply that n plus k minus 1 into t formula. Why? Because there, what is a small t? Here there are many small t. It is not uniform. So we have to rely upon space-time chart. Let us draw space-time chart. So I1, I2, I3, I4. First instruction is always independent. It executes its all stages without any dependency. Second instruction is dependent. Observe, second instruction, first S1 require 3 cycles. Once S1 is over, it switched to S2. Once S2 is over, can it switch to S3? No. Another S3 is happening. So it has to wait. It has to wait. Similarly, I3, S1 require 1 clock cycle. It can switch to S2, yes. Can it switch to S3? No. I4 require 1 clock cycle for S1, 1 clock cycle for S2, 1 clock cycle for S3. Now, what is the total time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So 11 time units. So total time is 11 time units. Now what is the speed up? Non-pipelined time by pipelined time, that is 19 by 11, that is some 1.7, maybe 2, something like this. So if there are non-uniform stage delays, then this is how you calculate pipelined time, and summation is non-pipelined time. Alright. Now, in this space-time chart, if you observe, during time unit 7, during time unit 8, 9, 10, you observe those. During time unit 7, I2 status is idle. During time unit 8, I3 is idle. During time unit 9 and 10, I4 is idle. What these are all called? Idle cycles or stall cycles or wait cycles, you can call as. Good evening, Abhishek. EduArt, yes, it is there in ECE also. Alright. Now, so whenever there are stall cycles, what is the effective speed up? Before that, the time with respect to stalls, we can say for n instructions, number of instructions into now stage time k into n plus k minus 1 whole into t. Now I want the time with respect to stalls. There may be ideal CPI, means a stage may not have stall, so I am taking ideal CPI. Srikant, I have already told a relation between efficiency and throughput. Efficiency by small t. Efficiency with respect to small t is throughput. Stage time is throughput with respect to stage time. Now, how frequently the stalls occur, and once stall occur, how long the stall would be, and what is the cycle time. There is a derivation for this, guys, but currently this is not the right time to derive this, but I am just in rough I am telling. For one instruction if you take, in that instruction there may be stage without stall or with stall. So for the stage without stall, I am taking the ideal CPI, and if there is a stall, how long that stall is and how frequently that stall occurs. And one cycle means 2 seconds or 5 seconds or how much, small t is how much. Now, speed up, effective speed up with respect to stalls. Speed up is always non-pipelined time by pipelined time. This is n into k into t divided by n into 1 plus stall cycles frequency into number of stalls into small t. So just I am giving one simple way for deriving this formula, but there is a proper derivation, guys. I am telling again, there is a proper derivation for this. Right now it's not correct to take all the derivation. That's why I am directly giving you the formula. So that is k divided by 1 plus stall cycles frequency into number of stalls. Alright. So with respect to stalls, this is the effective speed up. And there you will find a derivation like S max with respect to ideal speed up. What is this speed up? In that way also we will calculate. Anyway, if you see a question something like this, 2010 gate question. A 5-stage pipelined processor has IF, ID, OF, PO, WO. So different names can be given for the stages. IF, ID, OF, WO stage take 1 clock cycle for any instruction. PO take 1 for add and sub, 3 clock cycles for mul instruction, 6 clock cycles for div instruction respectively. operand forwarding is used. What is this operand forwarding? If you observe the given instructions, there is a dependency. There is a dependency. Like I1 result is I2's input. I2's output is I3's input. Like this, there are dependencies. Operand forwarding is one technique to handle data dependencies. So as it is given, we are following or using operand forwarding, we may neglect dependencies. We may neglect the dependencies. Okay. Now, what is the total time in pipeline execution? Now, as per the given information, first, for our convenience, let us form a table. We are given the stages are IF, ID, OF, PO, perform operation, write operand. IF, ID, OF, WO takes 1 clock cycle each for any instruction. IO is what? I0 is mul, I1 is div, I2 is add, I3 is sub. This is mul instruction, this is div, this is add, and this is sub. For mul it takes 3 cycles, div takes 6 cycles, add and sub 1 cycle. Right? Now we know how to execute in the pipelined mode. No two similar stages should overlap. Right? So let us execute them. Let us execute. I0, I1, I2, I3. I0, IF require 1 clock cycle, ID require 1 clock cycle, OF, PO require 3 clock cycles, and WO require 1 clock cycle. Now I1, instruction fetch, instruction decode, operand fetch. PO cannot happen here, so PO happen here, which takes 6 clock cycles of time. Then WO. I2, IF, ID, OF. PO cannot happen here. Here PO happens. Then WO. So total how many clock cycles? If you just start counting, in this way, total number of clock cycles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. So total 15 clock cycles. So the answer is B. Now 2014 gate question. Consider a 6-stage instruction pipeline where all stages are perfectly balanced. There is no cycle time overhead. When application is executing on this 6-stage pipeline, the speed up achieved with respect to non-pipelined execution if 25% of the instructions incur 2 pipeline stall cycles. So we are given number of stages 6 and stall cycles frequency is given as 25%. And once a stall occurs, how long it is? 2 cycles time. We know speed up k divided by 1 plus stall cycles frequency into number of stalls. So it is direct substitution, 6 by 1 plus 25% into number of stalls, that is 6 by 1.5, that is 4. Okay. And there are many more questions from this pipelining topic. We will definitely see them in the score booster series, which happens in the next month. Today, currently we are just explaining, revising the important concepts. Okay, I believe your pipelining topic got revised with today's session. A gentle reminder about Gradeup National Scholarship Test, which happens tomorrow. So please do register and circulate it as much as possible. And for all my classes information, you can just please follow me on Gradeup app so that you will get all my classes information, guys. Sir, what all my classes means what? What classes you are teaching? You know, at 7:15 you can find my classes, right? At 7:15 definitely you can find my class, which is the current session. Along with this, any other class I am taking? Yes, guys, definitely. I am presenting my class details for this December month. Please take the screenshot and please circulate it as much as possible because these are all free sessions. At 10 a.m. on Gradeup app, I will be teaching the COA concepts. COA becomes simple by Satya Sir. Obviously, I will make it very simple. And at 5 p.m., I will teach algorithms concepts, all gate related. These two are on Gradeup app. And at 7:15 in the current series, 25 most important topics. Obviously, we all are teaching these topics. Please take the screenshot and circulate it in all the social networking websites like Facebook, Telegram, Instagram, Twitter, Facebook, WhatsApp, wherever. Let many people benefit out of it, guys. These are all free classes. Okay? Thank you. Tomorrow, Murali Krishna sir will teach number representation topic. Srikanth, which post you are talking about? Srikanth Amudala, which post you are talking about? Alright, we are happy to announce that in the GATE 2020 60 plus students achieved top 100 AIR from CS category, All India rank 4, All India rank 20, All India rank 39, All India rank 47. These students got benefited from Gradeup test series. So next time, I believe you will be here in the top 100. So take Gradeup Super subscription, with which you will get green card inbuilt. You can access all the mock tests designed by toppers according to the latest exam pattern, and all the courses are taught by India's best faculty. All your doubts gets resolved with full syllabus coverage. So why late? Take Gradeup Super subscription. Here is the fee. For 3 months 9,000, for 12 months 22,200, 18 months 30,600, 24 months 36,000. So more period you take the subscription, less you will be paying per month. Thank you guys. Enjoy Gradeup Super subscription. See you in the next topic, and tomorrow at 10 a.m. I believe people will join, and please share it to all your college friends also, because these are free classes. They may be helpful for them. I believe you will do it. Thank you so much. Good night everyone. Prep smart, score better, go Gradeup. Thank you. Srikanth, I don't think so. Currently I don't think so. NEELIT posts will be increased. I don't think they will be increased. Okay Srikanth, thank you. Bye bye.